Now I'm going to show you how to generate scatter plots and compute correlation coefficients for this dataset iris. In the previous video for descriptive analytics, we already analyzed this data and I introduced this dataset. It has 3 species of flower iris, Cetissa, versicolor, and virginica, and 4 different variables: sepal length, sepal width, petal length, petal width. And now I want to generate scatter plot for any variables that I want to analyze from this data set. Let's look at the process. I would choose a task, and I want to generate scatter plots. Click here, scatter plot. I want to generate 2D scatter plots, and I want to generate a scatter plot between sepal length and sepal width. You could just choose any of them for horizontal and for vertical, because these are not no variable is dependent on any other. I don't think sepal width is dependent on sepal length, but it's just that's how I choose. You could choose sepal width for horizontal axis and sepal length for vertical axis. In this case, it does not matter. And I'm only interested in sepal length and width for now. I'm not interested in petal length and width. So I would group them by species, and here I could choose many things. You can go through all of them. This is basically how you want to design your plots. So I would just leave everything the way it is, just choose the defaults, and then I would click run. It's going to take a few moments, and then we can see 3 scatter plots, 1 per species for both of these variables. This is a scatter plot for Cetissa species for sepal length and sepal width. This is for versicolor, and this is for virginica. So when I have these scatter plots, they give me some information how both of these variables are related to each other. As I can see by looking at this scatter plot for Cetissa, I can see, in my opinion, I guess there is probably a strong positive correlation. In my lecture, you could see if there's upward trend, then there's a strong positive correlation. And if they are dispersed and an upward trend, it's somehow moderate positive correlation. If there's a downward trend, then it's a negative correlation. And when the dots are scattered like this, they're dispersed all over the place, then probably there is really weak or no correlation. But I cannot say this for sure until I compute correlation coefficients. So let's compute that. Choose task, correlations. You'll have to choose the same variables again, but I want to mention one thing. Now SAS wants me to use the file which is located on the SAS server. Remember, I was showing you once you upload any file, it's loaded to SAS server, and it tells you the location of this file on SAS. So I can go back and basically it's on SAS server. I would just go back, and then I want to show you the location. So on SAS server, it's under SAS app. That was the path. So if you have read the path, you would remember it was SAS app, libraries, work, and the name of the data was iris. Okay. So I want to use that file for this task. And now it tells me, okay, you have specified the data set. Which variables do you want to use for computing the correlation coefficients? So I want to use the same variables that I used for generating the scatter plots, because I want to confirm my understanding about the correlations. And I would group it by species. I could also say, instead of analysis variables, both of the variables come here, because I could also choose one analysis variable and one is correlate variable, because I want to basically find a correlation between both of them. So let's do that. So basically, this is what I wanted to say. Sorry, it just came back. So sepal length or sepal width with the correlate with variable. So now you have analysis variable sepal length and correlate with sepal width, and group analysis by species. And in the options, I can choose what kind of correlation coefficients I want to generate. By default, it is selected Pearson, but I also want to generate Spearman correlation coefficient. These are the most commonly used correlation types, but others are also used. So I would just generate these two, Pearson and Spearman. And then everything else, I would just leave like that, but I want to export my results. So I would just click here, save output data. And then these are the different names of the Pearson correlation would be under this name, and Spearman with this name. You could read the names. And we're not generating them. So let's leave it like that for now. And let's see what SAS does for us. Click run. It's going to take a few moments. Okay, here we have three tables, not like three sets of tables. And I wanted to generate scatter plots as well. So I would modify task. So I forgot to choose it before. So basically, I want to show that, yes, if you forget something, you can always modify it. And in the outputs, you had this results. So I wanted to generate scatter plot for each correlation pair. You can make many selections here and then click run. It's going to update our results page. The results page has been updated. You can see the scatter plots are there. These are the scatter plots should be the same. They would give the same results as we generated before by using the task scatter plot. Let's go through these results one by one. For CITESA, for between both of these variables, we can look at this. So this first table tells you which variables were used for computing the correlations. And the second tables give you some summary stats. And the third table is for Pearson correlation coefficient. And the fourth table is for Spearman correlation coefficient. Okay, so we are only interested in the last two tables, which are the correlations for now. And according to Pearson correlation coefficient, there's very strong positive correlation because the value is 0.54. If you look at slide number 17 of my lecture, it tells you if it's greater than 0.7, it is considered a strong correlation, strong positive correlation, because there's no negative sign here. And there was an upward trend here in the plot. There is an upward trend, and when it's upward, it is a positive correlation. When it's downward, it's negative correlation. You can see slide number 18 for different kinds of scatter plots, their shapes, how they look like for positive and negative, strong and weak correlations. And this value is, it's less than 0.0001. This means that your results are significant. If this value is less than 0.05, that means your results are significant. Otherwise, they're not significant. So our results, this Spearman or Pearson correlation coefficient, both of them are significant, and we can say, yes, there is a strong positive correlation between sepal length and sepal width for CITESA. And so this is the scatter plot matrix, and this is a little bit nicer scatter plot where you have all the observations, p-value, and correlation coefficient. So if you had to show your results in any exercise, any assignment, you could maybe choose this picture. Just simply take a screenshot and crop it. And also these tables, I can say these tables are much nicer than the ones that we export in SAS, because those ones are really wide, and you really have to scroll right and left to see the results. So these tables are nice. You can take a screenshot and copy paste them in your assignment. And this is the same thing for species versicolor. You can see there is 0.52 correlation or 0.51. Although the p-value is it tells you that the results are significant. It's less than 0.0001 or is equal to 0.0001, but still the correlation coefficient by itself is 0.5. So according to the slide number 17, anything between 0.5 and 0.7 is a moderate correlation. This is confirmed by looking at the scatter plot. Here you can see they are slightly more dispersed than CITESA. And here we had the same guess that probably there's a weak or moderate correlation. So yes, this is confirmed by looking at our correlation coefficient. There is a moderate correlation between these two variables in versicolor. Matrix tells you the same thing. It's just that this upper plot is a little bit, it gives you more information, and the matrix, you could just leave this plot for now. For Virginica, there is probably no or really weak correlation, as we saw in our previous part. Here, they're all over the place. I don't see any. There is slightly a little bit of upward trend, but not very strong. Okay, let's confirm. Yes, it's 0.45 or 0.42 for Pearson and Spearman respectively. And the value tells you that yes, these results are significant because they are less than 0.05, but the value by itself is really low for correlation coefficient. So yes, this is considered a weak correlation because anything less than 0.4 is a weak or no correlation. Although this is not less than 0.4, this is a little bit more, 0.45 or 0.42. You can also say this is weak correlation, but definitely it's not more than 0.5. So it's not moderate. So yes, this is a weak correlation. You can also confirm it by looking at this scatter plot. There's an upward trend, but not very strong because they are just all over the place. And like sepal length increases and sepal width increases, but not for every flower. Like here, it is just not increasing. Here, they are increasing. So this is the end of our exercise. Let's look at the this option. If you can export these results, there are many. You can export it as a SAS project or any output file. Let's try to export them as an Excel file. You can play with it and export it in any format. So I would just do it as an Excel file for now on my desktop. Here I have all my results. Correlation, mean, standard deviation, number of observations, correlations. It gives me only one value for correlation. Like I generated Spearman and Pearson both, but seems like it's only giving me one. Seems like it likes Pearson more because it's 0.74 for CITESA for Pearson and 0.75 for Spearman. So it is 0.75. Seems like it likes Spearman more. Let's confirm. Versicolor is 0.517. Whether it's Spearman or Pearson, it's not important. It's just I want to tell you which one it likes. So 0.51 it's Spearman. It seems like it just chooses whatever comes later. Spearman overrides Pearson in this case, but this is not important. You could only generate one of them. I could be happy with that. You don't have to generate two. And probably I would specify in the assignment which ones you have to generate, or if I don't mention, you can generate any one. But you have to mention whether it's Pearson or Spearman because I'll be confirming your results by regenerating it. And then this is the file. You don't have the plots. And this table is okay, but these tables are prettier. So I would recommend taking a screenshot and cropping them. And these scatter plots are a little bit nicer, so you can choose them, although this is your own choice. So this is the end of our exercise. This is how you generate scatter plots and correlation coefficients in SAS and interpret your results. Thank you very much.